So in section 7.2 you learn about how do we use definite integral to find out the volume of revolution of a region around x-axis or around a horizontal line or around y-axis or around a vertical line, right? So we did like pi and then r squared, where r is basically the thickness of the object, okay, thickness of the solid. All right, now on this section 7.4 we are going to learn how do we apply the definite integral to find out the arc length and then surface area of a solid. Okay, so first of all, what do you mean by arc length? Because if you have a straight line like this, then you can find out the length of this line. Just measure that, right? Or put it on, move it to the x-axis and count how many units its length. Okay, but if you have a like curve like this, how do you find out the length? That the length of the curve is called arc length. Arc length. Okay, if the curve arc length, if the curve is not straight, then it is called curve, right? And then the length of this curve is called arc length. Now how do we find out arc length? Because if you have this point, let's say this point is, let's say 1, 2, and then let's say this point is, let's say 1, 4, you know how to find out the distance, right? What is the distance formula? Distance formula is equals to under the root x2 minus x1 square plus y2 minus y1 square, right? Whole square, right? This is the distance formula. If you know the 2 points and the length of the line joining those 2 points is that distance formula, right? You will take that as x1 y1, this is x2 y2, like that. But if you have 2 points on a curve, this formula does not give you the length of that curve, because if you use that formula, you'll basically getting that length, not this length, right? That arc length is definitely bigger than the length of that straight line there. So how do you find out the arc length or the length of a curve in such case? Is the material that we will be covering on this section. Okay guys, all right, let us suppose that y equals to f of x is the graph. This is a function, right? And suppose that the graph of this function is not a straight line, like the graph of this function is like this. Okay, now you are interested to find out the length of this curve. Okay, how do I do that? Is the idea is you divide this curve into so many pieces, tiny pieces, okay, so that each of the piece is like a straight line. Okay, now what do? You use the distance formula to find out the length of this piece, length of another piece, okay, distance formula, and length of another piece is distance formula, right? And the length of another piece is another distance formula, and then you add them. Okay, so what is the length of the first piece? Suppose that this is like x1 y1, this is like x2 y2. So the length of the first piece is, let's say that this is d1, the first piece is d1. Okay, that piece is d1. So d1 will be, so this is like, let us assume that the left point is x1 y1, the right point is x2. You do write x2 minus x1 square plus y2 minus y1 square. That is the length of the first piece. So length of the second piece will be d2 is, let's say that this is like x3 minus x2 square plus y3 minus y2 square, and so on. You continue that way, right? So that is the length of the another piece, and continue that way. So if you add all these, then the total length L will be summation. Okay, I runs from 1 through n, right? And then under the root, what do you get? You get xi. Okay, so you get xi minus xi minus 1. That is like if you take I equals to you can think like this is like x0 y0 x1 y1 x2 y2 x3 y3 x4 y4 and so on. Then they do like x1 minus x0 square plus y1 minus y0 square. Oh, sorry, yi minus yi minus 1 square. That will be if you take I equals to 1, right? So that will be I minus 1 square. If you take I equals to 2, then you will get that d1. Okay, so d0 is basically x1 minus x0 square plus y1 minus y0 square. Basically what we are doing here is, it is like this a is x0, this one is x1, another is x2, and then so on. Okay, now you see that. So let us suppose that let us denote like xi minus 1, that length. Okay, that length is delta xi. Okay, that length is delta xi, and then yi minus 1. What is yi? This is like y0, y1, y2, y3, y4, like that, right? So yi minus 1 is delta yi. Let us denote that way. Okay, xi minus 1 is delta xi, and then yi minus yi minus 1 is delta yi. Then what do you get? The total length is summation I runs from 1 through n, right? And then you get delta xi square minus delta y plus delta yi square. Did you see that? Now I want to factor delta xi out. What do I get? If I factor that delta xi out, then I will basically get like this. Okay, summation I runs from 1 through n. Okay, and then I will get like this: 1 plus delta yi over delta xi square, and then because I'm taking delta xi square inside, okay, I'm taking that delta xi square inside, but when you take out from outside the root, what will happen? That will become like delta xi will be outside, basically just delta xi, not delta xi square. So if you write that way, then it'll like times delta xi. Okay, now consider the case that the maximum of delta xi, because the delta xi may have different length. Delta x1 may have like 0.5, delta x2 may be 0.6, delta x3 may be 1.5, like that. Okay, so that may have different length. So consider the case that the biggest of these delta xi tends to 0. If the biggest tends to 0, then the smallest also tend to 0, right? All of them tend to 0. So meaning that if you take these pieces very, 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 very small, at that time, that summation will become the integral, that delta xi will become dx, right? And then this delta yi over delta xi will become the derivative. So when the norm of delta tends to 0, okay, when the norm of delta tends to 0, meaning that when you make this every sub interval very, 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 very tiny, okay, meaning that you are making so many, like infinitely many sub intervals there, infinitely many pieces there. Okay, in that case n will tend to infinity, so this summation will go to, so the L will become the integral, okay, a to b. You see that? Integral of a to b, and then under the root 1 plus dy over dx square, and then dx. That's what you get. Okay, so if you want to write slightly differently using the prime notation, that will become a to b, and then under the root 1 plus f prime square, or you can say y prime square, right? And then dx. This is the this is the length of the curve y equals to fx, y equals to f of x. Okay, but sometimes you may be dealing with the problem like if you have like x equals to f of y, then how much would what would be the formula to find out the length? In that case, it will be like c to d. These are the limits for y. Okay, under the root, so it will be like 1 plus x prime or g prime of y, and then times dy. it is like, here it is like y prime, right? But here it is like x prime, or you can write g prime of y and then square of that, right? Square of that. If your function is solved for x equals to f of y, then that's what it looks like. Okay guys, so let us do some problems from your book, and then in the textbook there are so many examples that you can look at. Those examples, they are like great help. Okay, those examples are very good help. And also, as I mentioned earlier when I described the syllabus, I was saying that there are some videos on the course website. Okay, on the web assign, you can just click a video related to a problem and so on. Okay, all right, let us do example question number 8 from the book. That is, find the arc length of y equals to x to the 4 over 8 plus 1 over 4x squared, and in the interval 2 to 3. If you draw the graph, this is what the graph look like. Okay, now we'll be using that formula directly. So what is the length? Length formula is, so length is equals to integral a to b under the root 1 plus y prime square, and then dx. That's the formula, right? But we have just y. What is y prime? So since y prime is equals to what is the derivative of that? It is like 4x cubed over 8 plus, if you move this to the top, it will be x to the negative 4, right? Sorry, x to the negative 2. There is 1 4 times. The derivative of x to the negative 2 will be negative 2 times x to the negative 2 minus 1, right? We're finding the derivative again to find out y prime. That will be 1/2 x cubed minus, because minus 1/2 2x to the third, 1 over 2x to the third. Here it is x cubed over 2, right? 1/2 x cubed minus 1 over 2 x cubed on the bottom. That x cubed is on the bottom, right? So that minus came from the derivative here. Now let us plug in into the formula there. So that will become, therefore, hence L is equals to the integral is 2 to 3, right? The limit of integration is 2 to 3 under the root 1 plus, it is like x cubed over 2 minus 1 over 2 x cubed square, and then dx. Okay, so how do I do that? Is basically 2 to 3. Okay, now you need to simplify that. 1 plus, this is like square, so you need to do FOIL that, this times that same factor. This is what you will get there if you FOIL it. Okay, that will look like x to the 6 over 4 minus 2ab. It is like 2 times a will be x cubed over 2, b will be 1 over 2x cubed. Okay, and then plus 1 over 4x to the 6, and then dx. That's what you get. So we don't know what is the root of that, but what we can do here is 2 to 3. Okay, so how much would that be? Look at this. It's like x cubed and x cubed cancel out because there is a product sign. 2 and 2 cancel out, so you get basically 1/2 left, negative 1/2. But there is 1, so 1 minus 1/2 will be positive 1/2. You can write like this: x to the 6 over 4, right? And then plus 1/2. Why is that again? 1 minus 1/2 left here. So 1 minus 1/2 will be positive 1/2 plus 1 over 4x to the 6, and then dx. Okay, if you try to simplify this, this is what you will get. You will get 2 to 3. Okay, and then basically there are many ways you can do that. You can make the same denominator there. Okay, you can do the same denominator. That will be like, let me write under the root. Okay, same denominator, that will be 4x to the 6. You see that? X to the 6, 4x to the 6. And then how that look like? That will look like, so 4x to the 6 and then times x to the 6, right? Because 4 divide 4, and x to the 6 times x to the 6 will have how much? X to the 12 right, plus this is 2, 2. So 2x to the 6 plus 1. That's what you will get. Okay, guys. So if you simplify this, what you will get is 2 to the 2 to 3. This will look like under the root x to the 6 plus 1 square over, that will be 4x to the 6. Oops. 4x to the 6. That's what you get. And then there is still dx and dx. Okay, that will be 2 to 3. Now let us take that root out, because there is square. This is also a square of 2x cubed, right? You can write like x to the 6 plus 1 over 2x cubed. You see that? That's what you will get. Okay, so and then dx. Now simplify that. That's what you will get, like 2 to the 3 x to the 6 over 2x cubed will be x cubed over 2 plus 1 over 2x cubed, and then dx. Right, now you find out the integral of this. What do you get? What is x to the cubed over 2? The integral of that will be x to the 4 over 8, because there is 2 already. X to the 4 over 4, there is 2 already. That's what you get. And then what is the integral of 1 over 2x? You can move that 2x, x to the negative 3, 1/2. So that will be minus 1 over 2. Sorry, because 1 over 2 is already, right? You can write like that. So you get x to the negative 3 plus 1 over negative 3 plus 1. That is plus there, but if you simplify that, that is times, right? If you simplify that, and then again the integral is 2 to 3. Okay, so what do you get? That's what you get, x to the 4 over 8 minus, if that is x to the negative 2, that is negative 2 here, so negative 1/4 x square, and then limit 2 to 3. So if you plug in this 3 first, 3 to the 4, 81 over 8 minus 1 over 4 times 9, 36, and plug into minus, and then plug into to all of this. So how much would that be? So let me plug in 3 first. 3 to the 4 over 8 minus 1 over 4 times 3 square minus, how much is that? Let's plug in 2. So 2 to the 4 over 8 minus 1 over 4 times 2 square. So if you do that, what do you get? You get 81 over 8. Let me use my calculator. Okay, so you will get 81 over 8. Okay, so 81 divided by 8 minus, how much is that? 3 times 3 is 9 times 4, 1 over 36, 1 over 36, and then minus 24 over 8 is 3, right? Minus 3, and then plus that, because when you distribute that, minus times minus will be plus. 1 over 4 times 2 square is how much? 16, right? 1 over 16. If I do that, I get 7.16. That is, if I press math and find out the fraction, I got 1031 over 144. That's a crazy fraction, right? 1031 over 144. That's what you will get. That is the final answer. Okay, guys. Alright, let us see another example. This example is example number 11 from your book. That is y equals to 3/2 x to the 2/3 in the interval 1 through 8. Okay, so actually you don't need to draw the graph, because we know that this is not a line, this is a curve, and we need to find out. So what is the formula for that? The formula is L equals to integral a to b, okay, under the root 1 plus y prime square and then dy, right? That's the formula. So what is y prime here? So here y prime is the derivative. There is 3/2 times the derivative of x to the 2/3 is n x n minus 1. That n is 2/3, right? So what do you get? That 2 cancel with 2, 3 cancel with 3. That is x to the 2/3 minus 1 is how much? Negative 1/3. That will be 1 over x to the 1/3. Okay, that's what you get for y prime. So what do you get then? Therefore, hence L is equals to, so L is equals to 1 through 8 under the root 1 plus 1 over 1/3 square x to the 1/3, right? 1 over x to the 1/3. So let me do that. 1 over x to the 1/3 square, and then dx. See that? So what you get from here is 1 through 8 integral 1 plus 1 over x to the 2/3, and then dx. You see that? Now what I'm going to do is I'm going to simplify this. What you get is 1 through 8. There is 1 in the denominator, right? So the denominator will have x to the 2/3. So x to the 2/3, right? And then you get x to the 2/3 plus 1. And then that will be dx. If you take the denominator outside, what do you get? You get basically 1 through 8, not infinity, okay? This is 8. 1 through 8 integral of x to the 2/3 plus 1, and then you get times 1 over x to the 1/3 is outside, right? Do you agree with that? Because you see that what is happening there is x to the 2/3 can be written as x to the 1/3 square. 1/3 square, right? And the square and then the root will cancel out. So that will be basically, if you take that root, that will be x to the 1/3. That's how I got it, right? So now how do you do this integral? Okay, to do this integral you need to do the u substitution. Set, let me use different color, set x to the 2/3 plus 1 equals to u. Then what do you get? Find the derivative. 2/3 x to the negative 1/3. 2/3 minus 1 is negative 1/3. Dx equals to du. So what will be the value of, basically you move this down, you get 2/3. Let me write the other side, okay? So basically this implies 2/3 x to the 1/3, 2 over 3 x to the 1/3, right? Dx is equals to du. So what do you get? 1 over x to the 1/3, x to the 1/3, and then dx will be 3/2 du, right? You multiply by 3/2 on both sides. So that's what you get. So this thing basically, this thing is basically 3/2 du, and this is u, right? So what do you get? And you can again, so you can change the value of u. So also what do you get here? When x equals to 1, what do you get for u? You get 1 to the 2/3 is 1 plus 1 is u equals to 2. When x equals to 1, you will get u equals to, when x equals to 8, what do you get? This implies u will be what? 8 to the 2/3, right? 8 to the 2/3 is basically 8 to the 2/3 plus 1, right? What is 8 to the 2/3? It is like 2 to the 3 times 2/3 in the exponent. So that will be 4 plus 1, right? Because you cancel that 3 and 3, so 2 to the square, that is 5. So your integral, the length is equals to, you can write 2 to 5, these are the limit for u, and then root under u, and then there is times 3/2 du. You see that? So that will become, there is 3/2, okay? What is the integral of u to the 1/2? It is u to the 1/2 plus 1 over 1/2 plus 1. And then integral, the limit is 2 to 5. This limit is for u, so we don't need to go back to x. That will be 3/2 times, how much is that? U to the 3/2 over 3/2 again. 1/2 plus 1 is 3/2. So you can cancel that 3/2 with that 3/2. You see that? So what do you get? And the limit is 2 to 5. So what do you get after that? Now plug in 5. What do you get? 5 to the 3/2, and then minus, plug in 2, you get 2 to the 3/2. You know what 3/2 means? 3/2 means 5 times 5 to the 1/2, right? Because it is like 1 plus 1/2. So 5 times 5 to the 1/2 minus 2 times 2 to the 1/2. So if you want to write the nice format, that will look like 5 root 5 minus 2 root 2. That's how you can do it, right? That is the final answer. So basically the idea is you need to know that formula, okay? This to find out the arc length, it is like a to b under the root 1 plus y prime square. You need to know that formula, okay? After you know that, this other thing are just the integral. Just sometimes you may have to do some trick. Sometimes you may have to do the u substitution and so on. Okay guys, that's how we find out the arc length. So in the next video I will present some more examples, and then I will present some examples on how to find out the surface area. Okay guys, thank you.